Welcome everyone to today's lecture by Professor Mohamed Hatha from Cochin University of Science and Technology. He is a professor and head of the Department of uh, Marine Biology, and he is not from a geology background, but his work focus on environmental microbiology with a particular focus on marine microbiology. So today, Professor Hatha will talk about climate change and marine ecosystems. So, sir, please take over.
Yeah. Thank you, Adira. Thank you for that crisp and brief introduction. Welcome everyone to this lecture. In fact, although I'm a microbiologist by specialization, my strong feeling is that everything is affecting everything and everything is interconnected, living and non-living, very intimate and indispensable connections there. So geology is very much a part of my interest, as well as oceanography, marine biology, climatology. I mean, the very basic level of it, or overall understanding of the Earth ecosystem functioning. I love to understand that. And this is more or less a kind of a general lecture, but if you have specific details you require, you can always ask at the end of the lecture or in between also, you can ask, no issue. So I'll start doing. This is a title slide where I'm just showing one image of Kerala floods 2018, which was basically an extreme weather event as a result of climate change. And it is happening very frequent. So we will deal this later. So one of that question is, whether the fundamental question is it planet Earth or planet ocean, right? So because we have 2/3 of Earth is covered by the oceans. I mean, more than almost 71%, it's the oceans, and the Pacific is covering half the Earth. Then Atlantic is the next big, and then Indian Ocean, and you have Arctic Ocean at the top. And all these oceans, this is a continuum, all are mixing together. And around this Antarctic continent, they're all mixing. Earlier, it is known as Antarctic Ocean. Now it is more, precisely as Southern Ocean. So we have, these are 5 major oceans you see there. Pacific, Atlantic, Indian, Arctic, all the 4. And then whether the oceans are basically very essential for modulating the weather and providing huge amount of resources. The only thing is we are not seeing it. The food production, there's a huge amount of fish in the oceans. The primary productivity in the oceans are very, very important. And most importantly, if you look at, this is known as giant ocean conveyor belt, where the heat from the tropics is carried away to the cold polar regions and start sinking and come back here as the bottom water current. So this is, heat dissemination system, and this is what makes Earth inhabitable. Now you have lots of planets. As of now, we only know Earth is an inhabitable place. I do feel there may be other planets where there could be forms of life, but as of now, we don't have much idea about it. And the most important thing which makes life possible on Earth is, the availability of liquid water on planet Earth. If the planet Earth was little more closer to the sun, all the water would have been evaporated. And if it was a bit more far, then the thing is that everything is, frozen. So the availability of liquid water is a prime requirement for maintenance of life on planet Earth. And the oceans are doing that job. Oceans only make life possible on planet Earth. So then the other important question is it possible to affect the oceans in a significant manner or alter the conditions of the oceans in a significant manner? It was considered very difficult because just simply because of the vastness of the ocean, whatever pollutants you throw in there, just get, dilution and mixing is a very important physical process, which will just simply make it insignificant quantity as far as the chemical pollutants are concerned or organic pollutants are concerned. Of course, I do agree that coastal oceans are fairly organically loaded, or some level of eutrophication is there, which we will see. Other than that, the open ocean, I mean, the exclusive economic zone is only around 200 miles from the coast. Beyond that, it is open ocean, where law of the sea is the rule, where everybody has a right, or everybody has, the right to use that open ocean. But he said it is exclusively belong to that country. So it was considered very difficult polluting the oceans, but the global warming has changed the scenario, and it has reached the tipping point where you are seeing the changes. The changes in the weather or the climate or extreme weather events is nothing but mostly driven by the changes in the ocean, or the warming ocean is pumping in a lot of heat, whatever, a lot of things happening. We'll see some of them. And you can see the climate change indicators, or if you have a doubt about whether it is happening, then you can see some indicators which are in the ocean. Like you can look at the ocean heat. I'll come back to the next slides where you will see a little more clear-cut picture. You can see the SST, how sea surface temperature is getting altered, and how sea level rise is happening, which is a reality, and many smaller islands are, they're just getting extinct. And the coastal flooding, which I experience almost every day because I'm from an island, I'm from a small island where I can see now almost 30% is uninhabitable. And ocean acidity, like the CO2 is basically then again mixed into the seawater, where it is becoming, but for the organisms living there physiologically, it is a very, very important thing, and they find it very difficult. You will see that. So here, then again, people still have doubts about it. Some of the basic questions which we need to look at, whether climate change is real. That is another question many people are asking. And then, is it anthropologically driven? Some people, even some very powerful people want to say that it is not anthropologically driven. It is simply a glaciation, deglaciation phenomena. And so that they can escape from the responsibility of, climate mitigation funding or activities. And what are the signs of climate change? So these are some of the basic questions which we will address in the next few slides. And then again, the other side, I put something like how costly are the damages? It is running into trillions. We will see that. Then whether we can prevent it, definitely not immediate. We can definitely alter things, as we have done in the case of reverse things, as in the case of ozone hole, which was nothing but thinning of ozone, or ozone concentration is getting reduced, where we globally, we decided not to use CFCs. We put ban on use of CFCs. The advanced countries accepted the treaty immediately, but the other countries, they slowly put some cheaper alternatives, and they also fall in line. And finally, what we have is a very good ozone concentration, which is preventing the entry of high concentration of UV, only UV radiation. So it is reversible. And the UV concentration, the ozone concentration will be as good as pre-industrial climate change is another thing where you can live with lesser ecological footprint, whether you can live in harmony with nature, whether you can invent things which are, reusable energy forms like solar, like wind energy, OTEC systems, geothermal energy. There are several, renewable energy resources, which if we can shift, and the world is progressing so well on that. I mean, in India, even in India, there are a lot of electric cars, solar generation is, power generation is exceeding the targets. This year, this government's focus will be on the wind power, targeted high production. And how can we contribute our wind? That is the most important thing. I understand the planet, the Earth program of Niigata University is basically addressing the last point, how we can contribute our bit. So the people will get a chance to visit different parts, different ecosystem, different field, understand what exactly the nature is, and how best we can contribute our bit to sustainably live on this planet Earth with little ecological footprint. So the question is climate change real? Yes, there are two schools of thought. One is yes and one is no. I mean, some of the very powerful scientists and, politicians, they say it is no. But, science says yes. And without science, everything else is fiction. Science is testable, repeatable, and, based on facts and believable. Of course, things might change as you accumulate new evidences. What you are saying now might get slightly modified, but the basics definitely remain the same, no doubt about it. And the vital signs of climate change, you can see here, one thing you can see has the global temperatures, which are, increasing, like you can see somewhere here. It is maybe 1950s and post 1950s. It was, it is like a kind of escalation or rise is very, very high, and it is very much in tune with CO2 increase in the atmosphere, which is currently about, 450 ppm. So these two, increase in CO2 and increase in temperature, are linear. It is not a part of normal glaciation, deglaciation thing, because that warming is very slow. The accelerated warming is definitely connected to increased fossil fuel burning and CO2 emissions. And you can also see here, like I put, we will see some more images later. So another thing, across the globe, you are seeing sea level rise. These are some of the projections. And this is already, some places it is even exceeding. This was the projection in 2010. And 2010, you see the floodplain, the storm surge is coming up till this. And this is exceeding in some places, as we know now. And this is the 2050 projection, where if there's a storm surge, it can go up till this point. And the floodplain, this is coming up till this. And then you can see 2100 projection. If you look at this, is definitely reaching almost here. The idea, the projections are basically done. The projections are done not to meet the projections. So see, the projections are getting real. The projections are basically to see what will happen if you don't act in the future, and what will be the situation. And then you start acting. Probably by 2100, you can maybe keep it at here, or even 2050, you can keep it at this point, by proactive, environment-friendly living, developing technologies which can reduce the input of CO2 into the atmosphere. So you see here how much population is affected, and sea level rise and population impact. You can see that if suppose 0.7 feet is almost 1.3 million is affected, and if it is 1.6 feet, it is 1.8 million affected, and if it is 3.9 feet, 4.7 million, and if it is 6.6 feet, it is 7.8 million. This is actually big numbers. And also, as you know, this Mumbai, Chennai, Kolkata, Los Angeles, Tokyo, Rotterdam, across the globe, Sydney, Melbourne, all these are coastal cities, because earlier it was only the trade was sea routes and the cities were developed along the coast, and at least 30 to 40% of the population is on the coastal belt, and the cities are along the coast. And this sea level rise, incursion of the sea onto the land, will definitely have a great impact. I mean, it is going to negatively affect. There is a massive exodus of people, exodus of city infrastructure to the interior. Otherwise, it is going to be, and that is going to be calamitous. That is going to be very, very taxing economically. And also another thing, say, if the seawater is coming in here, creeping in here and creeping further inside, what means these are all becoming saline soils, and the saline soils are going to affect your drinking water here, your agriculture is going to be here, all those things will be seriously affected. The plants will not be able to grow in high saline conditions. The saline intrusion of the groundwater will make it undrinkable kind of saltiness and the health hazard. So such issues remain. So here I'm just going to show you some of those indicators of how the world oceans are changing. These are all again, projections by NOAA, National Oceanic and Atmospheric Administration by USA. This is CSIR Australia, and the other two models, which you can see, all models are showing how much ocean heat content is, how much it is going to increase by 2025. That heat content is not just going to come just like that. It is definitely going to come as a result of warming. Then you can see, if you look at changes in the sea surface temperature, you can again see, you will see it is actually now around 2.5 to 3. And like you see, I've read a very recent report, maybe 2 days back. It is saying for the past 12 months, and that's just exactly 1 year, the temperature is only on the rise. Land-based temperature as well as sea surface temperature, SST, you call it as SST. And, people are a bit scared about whether if it goes like that, because every month is breaking the record of the previous month. That is what is happening for the past 1 year. And, these are all not just this point, it is just 20. I mean, as far as global temperature calculations, there are 36,000 reference points across the globe. Will calculate. You cannot get what Arctic is almost 3 to 4 times that of warming elsewhere in the globe. It is almost warming at 5 to 5.5 degrees centigrade. I have been there 3 times to Arctic. I have seen how it is ice-free. The Arctic fjords are more or less ice-free. The tundra is expanding. I put some slides there later on. And you can also see the global, sea level changes, cumulative sea level changes. You can see the 2 projections by NOAA and CSIR. And this is, you see, this is the satellite observation. Satellites giving you a global picture. Satellites are actually continuous real-time thing. They're always airing this, imagery to the ground stations and giving us, very clear picture where the cloud is building up, where it is going to rain, where there's a cyclone is developing. And if you look at this is satellite measurements, and tide gauge measurements are more or less equal. I mean, it is no big difference. It is more or less same. And you can see some data is available, how the coastal flooding has increased in US based on the National Oceanic and Atmospheric Administration. You can see during the period 1950 to 1959, you were seeing only, around 3 times or 3 incidents of flooding per year. But if you look at 2013, 2022 period, it has gone up to 12 times. I mean, almost 4-fold increase in the flooding of all these coastal places. Like you can say, Friday Harbor, Seattle, San Francisco, Port St. Louis, Los Angeles, La Jolla, San Diego, all these places. And this side you can Bar Harbor. Portland, and many other, coastal cities, the flooding has increased almost 4 times. And how does the oceans modulate the climate and weather on land? As I said, the giant ocean conveyor belt, this is actually sea surface temperature distribution. The ocean influences weather and climate by storing solar radiation because it's a huge amount of water in the oceans. And the specific heat of water is very, very high. If you wanted to boil some volume of water, you know how much energy you need to give. For raising 1 degree by 1 gram of or 1 cc of water by 1 gram is a huge amount of heat. So you think about the quantum of water in the oceans. So it just absorbs with the minimum change. And also it also take the heat from the tropics to the polar regions in this circle. And this way it is another circle. This is in the northern hemisphere, it is clockwise. The ocean gyre is in the clockwise, and the southern hemisphere, it is anti-clockwise. Both ways it is taking from the tropical, one branch is coming, going like this, and here one is going like this. In both ways, it is carrying the heat to these regions and finally distributing there, the excess heat. And I'm just, showing some events. So the major issue with the climate change is extreme weather events. Extreme weather events across the globe. I'm just putting some imagery here. This is our place. This is Kerala. After 2018 floods, huge, it was a huge calamitous flood. It was. It is considered as Maha floods, Kerala Maha floods. 2018, you can see this is what we witnessed. The aircrafts were grounded, no operations. You can see this is the first floor, the building, the houses are completely underwater. And almost all areas, I just couldn't believe from this much water came. The water just came, torrential rains for nearly a week. And it just simply pumped in, filled all the dams, and it started overflowing and also released for safety issues. And it was a situation like this. And you can see here, there is nobody is spared from these extreme weather events. Whether you are a developed country, whether you are a developing country, nobody is spared by the, these climate change events. You can see this just before my arrival in 2018 in Japan. It was, this was there, then there was drought also was there, and the flood was also there. And you can see this California, this is, again, this is Florence cyclone in near US coast. Then again, 2011 Japan tsunami. We can see Dominican Republic in 2017. You can see this is in Austria, the kind of ice you can see. And you can see this was a major, this is Oki cyclone, which actually killed more than 250 people along the coast of Kerala. And this is another tropical cyclone, which is known as Taukke, which is again was, unfortunately, there was no loss of life. But of course, along the Gujarat region, there was a lot of infrastructure destroyed. And you can see how wildfires in Australia, California, and different parts of the world, Germany or China, are all experiencing floods and huge infrastructure loss. So here, this one point which I wanted to highlight here, this is Arabian Sea of Indian Ocean. And this is where we live here. I'm at this point at Cochin. Well, this area was relatively free of cyclones. In fact, the cyclones were mostly in the Bay of Bengal. But now there are frequent cyclones in this part of the thing, and it is more frequent and more intense. And even just a week back, there was a torrential rain. It is like a cloudburst. In just 1.5 hours, 15 centimeters of rain. So here, whether the extremes are becoming more frequent, that is another question which we wanted to have a look. And if you look at, see, you see the events, like if you wanted to look at geophysical events, or if you wanted to look at meteorological events, if you wanted to look at the hydrological events or climatological events, everything is on the increase. You see geophysical events, you can see it is increasing from 1980 to 2015. It is basically on the rise. Meteorological events are much more. They are actually much more increase in the meteorological events from 1980 to 2015. Hydrological events are even still more. Hydrological events are actually, it is the flooding kind of thing is happening much more vigorous, much more frequent. And climatological events like extreme temperature, drought, wildfire, those things are also, if you look at, these are all very small stems here, you can see here, these are all really become bigger and more frequent. So it is now convincing, or people of the world are almost convinced about climate change. People of the world are actually requesting their governments to allocate more funds for climate mitigation, or asking them to develop climate-friendly technologies. So then the question is it anthropologically driven? Yes. And there are some confusions remain over glaciation and deglaciation, or some people only. Now it is more or less clear-cut proof is there. It is due to increased fossil fuel burning and more CO2 into the atmosphere. So only very few people are still skeptic, but that very few people involve certain big wigs also, or certain powerful people also. And accelerated warming since 1900s linked to human activities, industrialization and increased fossil fuel burning. These are all definitely required. I'm not against this, but how we can do this without burning much fossil fuel, or with the help of alternate energy sources. And you can see some signs of climate change, like a frequent occurrence of extreme weather events, which we have seen: heat waves, droughts, wildfires, cyclones, heavy rainfall with floods, heavy snowfall, ocean acidification. We will come back to that little more detail when we discuss the marine impacts, and which could lead to species extinction and decreasing crop yield. As I said, the floods or droughts are basically destroying a lot of crops. That is one way. I mean, the farmers are bearing the brunt of that attack. And the food security is basically a threat, at least in, and many places, because there is demand for more food as the population is now crossed 8 billion. But, these extreme weather events are destroying the crops. Also, the saline intrusion in the coastal belt, which is generally considered as a fertile belt, where, the crop, we are unable to grow the crops, or crop yield has become very less. So probably we will have some transgenic plants, genetically modified varieties of crops, which can grow in high saline soils, which can grow with less amount of water, which can resist their own pests. And those kind of things are what science is looking at, developing transgenic plants, which can do well under extreme weather conditions. This is again abandonment of populated areas due to rising sea levels. See, I am from an island like this. I am from an island which is very nearby, where I can see, I've been to these places. I was in South Pacific country, Fiji, for nearly 3 years when I visited Solomon Islands, then Tonga, then Vanuatu. These places I have seen, they're all small island nations with the people around 15,000, 20,000 people, and their coastlines are sinking very rapidly. And those people from those countries also have a priority for as immigration to other developed countries like Australia or New Zealand or US. They have a priority status, because they are it is none of their footprint is basically very less. But whoever does that, the warming happens or happened already. Ice caps are melting. I have witnessed it several times. Pumping or releasing a lot of water into the sea, and sea levels start rising. When it starts rising, definitely these small island nations become non-existent. I know many of those islands in the Pacific will not be there after maybe 50 years. It's very difficult. Even my island, I am seeing 2050. I mean, it is going to be very difficult. It is a lot of people there. It's going to be pretty difficult, because I see 30% is uninhabitable now. It is all flooded all the time, 24 hours. So now we will see the climate change impacts on coastal and marine ecosystems. We see some of the changes, ocean physical changes, like how warming and currents are affecting the systems. We will see how the chemical changes like ocean acidification is affecting, and effects of global change versus natural variation. And we will see how it is going to affect the freshwater supply, and how sea level rise is going to impact populations, and the loss of sea ice, especially in the Arctic ecosystem, which I've seen, it's a very serious issue there, especially some of those keystone species such as polar bear. They're, facing a survival threat because they are unable to hunt, or proper seal holes are not there. I have put some images, I'll show you later. So here, this is one thing which across the globe, what they are saying, with the rising sea surface temperatures, the algal bloom or the harmful algal blooms are on the rise. Harmful algae are a kind of algae. They produce certain toxic byproducts, and these toxic byproducts or toxic extracellular products like toxin. There are several toxins like neurotoxins. There are other diuretic shellfish poisoning is there, neurotic shellfish poisoning there, amnesic shellfish poisoning there, then paralytic shellfish poisoning there. These are all, like the algae basically eaten by the bivalve shellfish. They are filter feeders. When they start feeding, and see, each and every one of us are connected in the food chain, no doubt about it. Everybody is connected in the food chain. Whether you are a vegetarian or a non-vegetarian, whether you are a seafood, you are definitely connected to the plant. Even if you are a seafood, eating person, you are connected to phytoplanktons in the sea, in the ocean. Phytoplanktons only can trap the sun's energy. That will be eaten by zooplankton, then small fishes, big fishes, and goes like that. So even if you are not eating these things, like not a meat eater, you are basically connected in this chain because the network is like that. Maybe the manure from this thing goes into the production systems and comes back. So here, the climate forcing is happening. What that is that ice free, then light is getting inside. And if there are more CO2 is mixing, if more CO2 is mixing, then it means then you have, it is becoming acidic, so pH is changing. And if it is, this thermal gradient is very strong, then you have a stratification, you have thermoclines forming sometime beneath, and the nutrient supplies are getting limited. If it's a well-mixed ocean, you have a lot of which is
Hello, sir. Sorry to
fish
interrupt.
or even to the people, who are eating the fish. Or you can say phenology, like some of the algal composition might change. Toxic algae becoming more, and useful algae or beneficial algae's number may be less. Their diversity becoming less, the toxic algal diversity becoming more. And the distribution, biogeography, like earlier days, the temperature in the subtropical regions and polar regions are pretty cold. So the tropical ones are unable to extend their reach. But if you look at now, many of these tropical species are extending their northward reach because the water is much more warmer, much more inhabitable for a tropical species. So they're extending their biogeographic spread, and so which is causing issues. And if you look at again, I'll show you another thing. If you look at this one, this is a diuretic shellfish poisoning, episode. See, the algae basically grow here. The this is toxin is ocadoic acid. So ocadoic acid producing harmful algae, their blooming taking place. They are eaten by zooplanktons. And the zooplanktons are taken by the mollusks, which are cultivated on raft. It's a raft culture on the ocean surface, and this is going to come to the human, and it is going to cause a diuretic shellfish poisoning. So you can see the oxalic acid producing phytoplanktons are eaten by zooplankton. What is talking? This is climate change and algal blooms. The rising ocean temperature drive more intense and longer lasting toxic outbreaks, which result in, all these are short forms. This is DSP means diuretic shellfish poisoning, ASP means amnesic shellfish poisoning, NSP means neurotic shellfish poisoning, and PSP is paralytic shellfish poisoning. So they result in massive fish kills, and sometimes they also associate with pathogenic vibrios or pathogenic bacteria, and the algal blooms support the growth of pathogens side by side. The exudates from the algae support the growth of pathogenic bacteria, and those pathogenic bacteria affect people who are using the system for recreation like swimming or other, or taking seafood from such a toxin-laden environment, right? So here, I put a box here. Why are algal blooms dangerous? Algal blooms can cause health problems if you touch toxins in the water. These may include skin irritation, upset stomach, hay fever or allergies, neurotoxic effects, which includes trouble breathing, and at very high levels, even mortality. And those symptoms, any of those symptoms, one should immediately consult a doctor. So here, another very interesting phenomena you can see here. As I said, when the toxic algal blooms happen, some of the bacteria, pathogenic bacteria, get associated with them. You see here, this is a picture in 1973, and this is pathogenic vibrios. You have Vibrio cholerae, yellow color, Vibrio parahemolyticus, green color. For geology people, it may be a bit difficult, but don't worry about it. These are a kind of pathogenic bacteria. This is Vibrio vulnificus. So you see 1973 till 1990, there are hardly one or two or less numbers. But if you see the situation after post 2000, if you look at, it is much higher. The frequency and the numbers are very high, and they can clearly cause human diseases. This picture is basically from my own island where I am living. This is a road. What you see here, this is basically a road. I mean, this you can go by your car. This you can see the tarmac here. You can see the asphalt here. So this is, I have a small plot here. So I'm trying to do some ecosystem restoration. If you are interested, I can give that lecture sometime later. So here, I'm doing some novel strategies to do that. It is working to some extent. I can show you. So here, you see the human dwellings. This is a water canal. This is a seafood or aquaculture farm inlet. This is the road. This is another small aquaculture field, and people are living here. This is a mangrove, and people living here, and all these places. You see, the entire water body is one. And the situation is like this many times of the year, it is all the same. And this is maybe half a kilometer from the beach side. So where the problem is, when it is flooded all the time, the septic tanks cease to function. Their septic tanks cease to function. Their house is full of water. They put certain stones and keep their bed over those stones. And also, when so much water is there, everything is merged, everything is mixed, and the pathogenic bacteria from the septic systems can get into this, or contaminated water canals can get into this, and it can go to their drinking water wells. And it also provides an ideal condition for horizontal gene transfer among bacteria. So the higher species always doing gene transfer only from parent to offspring. The transfer is only vertical. But in the bacteria, they does horizontal gene transfer. They can transfer from unrelated species to other unrelated species. Basically, I do a lot of research on that and looking at how horizontal gene transfer is affecting antibiotic resistance development or different combinations of antibiotic resistance development. And you can see here, next one, you see here ocean acidification. Ocean acidification, basically CO2, when the atmospheric CO2 is very high, we are now saying it is almost 450 ppm. So 450 ppm in the ocean is, so there is always air-sea interaction. Air-sea interaction, even your surface currents are basically driven by the wind or wind-driven currents. The wind is providing energy onto the surface and they start setting the waves in motion. Similarly, the gaseous component, based on the partial pressure differences, it get diffused, it get dissolved into the water. So when there is more CO2 in the atmosphere, more CO2 is getting diffused or dissolved into the water, seawater, and resulting in forming carbonic acid. Carbonic acid is a weak acid and it is resulting in ocean acidification. And the ocean acidification is a big problem for many of these, I'll show you some image, many of those shell-forming organisms like bivalve shellfish, molluscans, where they cannot form the shells because it just dissolves at low pH. It starts dissolving in low pH. So they cannot, it is very, very hard for them to build their tough shells. You are going to see, this is one image of a healthy coral polyp. The healthy coral polyp where a lot of reef building corals and there is a lot of growth there. But when it is acidic, they are unable to form such a structure like this. They are growing individually, but that calcareous structures in between them is very difficult to make because the sea has become acidic. So they become now independent polyp like this. And these connections, these calcareous connections in between those polyps are missing. So which is a big issue. And also you look at another thing. See, this is pink salmon, which is a very favorite food, maybe not in India, but in Europe and other US and other parts. It's a very important thing. So they eat a lot of pteropods, which is something like this. This is a pteropod. The pteropod, but when the pteropod is a molluscan, a shell-forming molluscan, and when it is acidified ocean, the pteropod concentration actually drops. If there is a 10% decrease in pteropod production, that leads to a 20% drop in pink salmon body weight. Because pink salmon eat so much of them and gain good weight. And if due to acidic oceans or ocean acidification, pteropods are becoming less because they find it difficult to form the shells and survive, then the pink salmon is going to less number of them. And if there is a 10% decrease in pteropod production, it will lead to a 20% drop in pink salmon body weight. So that is a very commercially important or economically important change or impact as a result of, that is also the same case with the Japanese chow, right? And I will also show you another thing, which is in the Arctic biodiversity, how the changes in, climate change is affecting Arctic. Arctic, it is actually warming almost 3 times elsewhere on the globe, which is actually known as Arctic amplification. So whether in one way you can consider Arctic amplification is good. One thing is that the sea ice is melting. Sea ice melting means more sunlight will go into the ocean. When more sunlight will go into the ocean, more primary production can take place. Similarly, on the tundra is a land-based thing. That's a tundra biome. The tundra biome, the land-based ice cover is just getting cleared. So a lot of sunlight is getting and the tundras are expanding. So generally there is more food supply, both in the ocean as well as on the land. So when there is more food supply, naturally it will attract a lot of migratory species to come and feed. So a lot of birds are coming. That is one of my research area. I'm tracking their migration also. I'm doing the spread of antibiotic resistant organisms. My student will go to Arctic this 28th. Her visa has come today and she will be leaving for 1 month expedition there. So it is attracting. More food supply naturally means more fish and more migratory species into the system. But another thing, I'll show you another image. So here, another thing maybe you will see advantages is like less sea ice means the Arctic Ocean is navigable by big ships. The ships can cut so many hours of travel time by directly going through the from Russian side to the other side. It is very easy for them. So they need to put less amount of fossil fuel to run the ship. Those are on the positive side. But this, if you look at the flip side of it, so this is actually positive, how the production is increasing. You can see production is very high in the compared to the other, I mean, maybe if you look prior to 2010, it is like this, but if you look at after that, it is very high. So here, when the production is high, there are certain health issues. Like the migratory birds are not coming just like that. They're coming with their own microflora from elsewhere. They're coming from a lot of pathogenic bacteria in their gut, because they're migratory birds. They have a lot of stopovers at different places. They mingle with the local population. They might feed on the sewage and then they take rest and gain body weight and take the next big flight. And similarly, they do like that. So naturally, once they come, they are bringing in a lot of pathogenic microbes into the system. We have published several articles there. These are all our recent publications. And we could see the antibiotic resistant bacteria, pathogenic bacteria coming through migratory birds, which is an issue for the Arctic organisms because they never exposed to that kind of organisms. And there is an issue of disease and mortality. A kind of a thing happening in the Antarctic right now. There is highly pathogenic avian influenza is killing a lot of penguins there in the Antarctic. And they're connecting it to migratory birds coming in there from different places for breeding. Because when it is winter in the Arctic, these migratory birds, some of them like Arctic 10, they take a long flight to Antarctic, which will be in the summer and which will be protective. And they goes there. So they connected to these migratory birds which are visiting Antarctic that time and causing this kind of highly pathogenic avian influenza. And also this, when I put this image here, this giant ocean conveyor belt, the water is moving, not just water alone. It has got a lot of, microflora, a lot of algae, a lot of invasive species going in from the tropics to this side. When it is ice-free and free, they'll push their warm tongue further and further and further. Not only just the heat and water, it also takes a lot of invasives and a lot of pathogenic stuff from the tropical regions to the polar regions. So you see here, this is an ideal situation which polar bear likes. It is just waiting in front of a seal hole. When the seal comes to breathe air, just lift its head, this will just snatch the seal and it is a very easy prey. And it can maybe for the next 1 month or so, one seal is sufficient for a polar bear. But you see, because of the accelerated melting, that kind of systems not there now anymore. They cannot hunt because if a seal comes here, it cannot do anything. Seal can also see them and it'll just swim away. It's very difficult. I have even seen one very recent video done by this British, photographer or documentary producer. He is showing how the polar bear, larger ones, are swimming across the, fjords. And the young ones are finding it difficult. In normal case, they should be getting some sort of a sea ice in between to rest and then cross. And they're very, very, very difficult, and some of them might even die. And you'll also see some of the things like northern species. There is a northward movement of species because the temperature is warming. And these tropical things having a better time there, expanding their geographical reach. And you can also see some things like there is a lot of, organic matter dumping in the coastal oceans, which is resulting in a kind of suboxic or anoxic conditions across the coastal regions of the global oceans. So what happens? This in Indian Ocean, it is almost up to some 200 to 800 meters. It is this hypoxic region, or you call it as OMC, oxygen minimum zone. When the oxygen minimum zone, there are not many organisms can live there. There are less number, diversity is very less. So such suboxic or anoxic areas spread, then a lot of mass mortality of fish and shellfish or other marine species. And then you can also see some species shift, I'll show you this one. See, this is in the late 1960s. The catch was much more valuable. This is nothing but shrimps, which is a high value item. And it started changing to less, fair value stuff to 1970s. And if you look at the 1980s, they were low value. The species composition has changed. The warming oceans are still doing a lot of shift in the population. For example, in our area, we see a lot of jellyfish these days. And jellyfish is a big problem. The fishermen are unable to operate their fishing nets because they get entangled. They cannot catch anything, other kind of stuff. And once the summer season ends, when it starts raining, all of them will go die because they cannot survive in low saline waters. And once they die, they sink to the bottom and start decaying and causing anoxic conditions in the shallow waters, which is again a problem for other aquatic species. So I think that's it from my side. These are some of my students. Many of them now completed their PhDs and moved out, and some of them, some new faces are there. This picture is little old picture. So I hope those who wanted to ask questions, I am very happy to take questions. Anyone who is interested can raise questions. Adira, over to you.
Thank you, sir. Thank you for the interesting lecture on climate change and its impacts on marine
Just
ecosystems.
bit more louder.
Hello.
Yes, Adira, please.
Thank you, sir. Thank you for the interesting lecture on climate change and its impacts on marine ecosystems. So we will wait for questions.
Okay. Yeah, I am waiting for. Oh yes, chat. There are a lot of. There are a lot of. There's some, but I don't know whether there is questions. That's all names there.
Oh yes, that is their
And
attendance.
that's their Utpala Hansani, Peradeniya University. Arjun Raj and yeah, Somdeep. I see some of our students also. So any questions, please? I don't know whether it was, I don't know, because our accent is little difficult thanks a lot for enlightening me. I was interested to hear you speak about what need to, that was what need to be done to mitigate further losses. Yeah, that is an excellent question, a very relevant question. The most important thing which you can do is how you can sequester more carbon dioxide from the atmosphere. One way is definitely a massive afforestation or planting trees or artificial systems. I have seen artificial trees, one technology, it's kind of lamppost kind of thing, which will actually absorb CO2 and convert it into something else. The other thing is that, your dependence on fossil fuel has to be reduced significantly. But unfortunately, many countries, the still coal-based industries are still active. Even US is opening their coal fields, like in Pennsylvania state and other states. India is actually having a lot of coal-based production. When we don't have production, we are even, there sometimes the coal mines getting flooded. They also even import from Australia, has got a lot of coal mines. So that is to be replaced, at least to a great extent, to be replaced by non-conventional energy sources. renewable energy sources like sun, solar and wind power, geothermal, ocean thermal conversion system like OTEC. And there are a lot of scope, a lot of things, a lot of initiatives are happening. Then you have to have clean technologies. And also another important driver is nitrous oxide from the marine systems, because these organic loading result in anoxic conditions, and under anaerobic conditions, certain kind of bacteria which they can convert the nitrite to nitrous or denitrifying forms, which can, this nitrous oxide is again a very powerful GHG or greenhouse gas. Similarly, you have methanes coming from, like these marshy systems. Even rice fields are contributing a lot of methane. So such things we need to look at. Next question, sir. What do you feel a student could do connect academics to the real world, which seems to be lack there, specifically in terms of nature awareness? Actually, I really don't believe. I mean, whatever is these environment-related things are easily practicable for anyone. The basics are very, very, very simple, and it is easily adaptable by anyone who is interested. I think the problem is with the mindset. The mindset is like, people feel nature is, like a thing for everything. They don't think that they are part of nature. Basically, everybody is part of nature. Nature is the all-encompassing thing. And the humans alone cannot, go on just like that. That will crash. Definitely it is crashing. It is bound to crash. Or it is becoming more difficult to survive. As you see in these times of intense weather events or extreme climate weather events, everybody is suffering. Whether it is US, Japan, Australia, China, India, everybody is suffering. But still, the people, not really understanding the gravity or not really interested in change, or because climate mitigation things will work only you invest in money now, and you realize the fruits maybe after 30 years or 40 years. But you don't see, I mean, then you are a little worried about whether I need to put so much money now, almost governments. But instead, when something happens, you put some systems in place and then you salvage, but that will not work for longer term. It is not going to be sustainable. So the damage caused by extreme weather events run into trillions, while the mitigation strategies or the cost will be, or climate adaptability cost will be running into billions only. The other one is definitely in trillions. So that difference need to be, ingrained very powerfully into the minds of people, those who are in power, as well as ordinary people. Then they will start acting. Then another question, Antonio Ben Clapp. Certain coastal regions like the west coast of USA are artificially reintroducing kelp for us to boost the region's productivity and due to their excellent carbon fixing capacity. Would this be a long-term solution for global climate change in your opinion? Actually, I personally believe in any carbon sequestration system, and the most powerful ones are like algae, these kelp forests, or seaweeds, or land-based forest cover, or grass, or whatever. I personally grow a lot of greenery in wherever I can. That is my motto, because at least to trap the thing, CO2. It might be the issue might be. See, when you are keeping kelp in certain areas which is not inhabited by kelp at some point of time, or the kelp is going to be as a dominant kelp forest is going to dominate some area, then there is definitely going to be a population shift, because every organism are not adapted to a kelp, ecosystem or kelp forest. So there could be some population alterations. There could be effects on the fish stock. There could be effect on other crustaceans and other species. So that need to be studied. But in a way, I mean, like absorbing CO2, definitely, I think it is a positive side. You can also do artificially on land, also multiple vertical systems you can do. Those are all possible. it is a solution to some extent. It can do something, but it has to be assessed. What are the other, once you start setting in these things, you will also see there are several other things maybe happening side by side, that you need to wait and see what is the kind of change it is going to cause in those regions, whether it is a positive or a negative. Somebody want to speak, or somebody wanted to ask?
No, sir, please continue.
Hi, Adira. Yes.
You can continue, sir. It was from
Yeah.
next
If there are
story.
questions, I am ready to answer. No issue. Those who wish to interact, please. I am not hungry.
It's your lunch time there.
Pardon?
It's your lunch
Yeah,
time
now it
there.
is 2 o'clock, but that's no worry. You can just keep chatting. No issues. We can. I think I love to talk to the students. Okay.
Okay, sir. Thank you. Thank you so much.
Okay. Thank you. I learned a lot. Thanks. Yeah.
Okay, sir. Thank you.
Okay. Thank you. I'm signing off.
Okay, sir. Bye.
Yeah.